In this video, we are going to talk about graphing sine and cosine graphs, some of those key features, and how we handle transformations. So first, let's graph the sine parent function. So we're going to fill out this table of values. So when x is 0, what is the sine of 0? Sine of 0 is 0. What's that sine at pi over 2? It's 1. Sine at pi is 0. Sine at 3 pi over 2 is negative 1. And sine at 2 pi is 0. Now I'm going to label my axes. So I'm going to label 0, 0. And I'm going to kind of space out my x values. So pi over 2, pi, 3 pi over 2, 2 pi. And then my y values vary between 0, 1, and negative 1. So 0, 1, and negative 1. Now I'm going to plot my points. So 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi. And when we're graphing these, we want to make sure that they look rounded because they're like a wave, not pointy. And also keeping in mind that we're only graphing a section of this graph, that the graph would continue going in both directions. All right, so let's fill in some of this information down here. Some of this vocab will be familiar, others will not. So for domain, we know that those are our x values. So if I know this graph is continuous, I can see that my domain would be negative infinity to infinity. My range is my y value, so if I'm looking for the lowest to the highest point, I can see it goes from negative 1 to 1. And we're going to put those square brackets because we are touching at negative 1 and 1. Symmetry. Symmetry of this graph is about the origin. And this is true for all sine graphs. The period. This is the length of the cycle. So in this case, it's from 0 to 2 pi, so the length would be 2 pi. Sinusoidal axes. This is the axis that represents kind of the center or the middle of our graph. So in this case, the middle of our graph is here, and so that would be at y equals 0. Amplitude is the height of our wave, so it'd be the distance here or the distance here, and our amplitude is always positive, so in this case my amplitude is 1. My maximum value is my highest point, which I can see is 1. My minimum value is my lowest point, which I can see is negative 1. My inflection points are where your graph switches from a minimum to a max or a max to a minimum, and that's happening at 0, at pi, and at 2 pi. So it's happening at 0, 0, pi 0, and 2 pi 0. Now let's do the same thing but for our cosine graph. So we're going to fill in this table. So cosine at 0 is 1, cosine at pi over 2 is 0, cosine at pi is negative 1, cosine at 3 pi over 2 is 0, cosine at 2 pi is 1. So I'm going to label my graph very much the same as I did my sine graph. And then I'm going to plot my points. So 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, 2 pi, 1. And again, this shouldn't be a V shape. It should be a curve. It's kind of like a circle that we've spread out. And so cosine, once it hits those maximums at 1, it'll actually curve back down. So when we're graphing, we want to show that the cycle would continue that way. All right, so similarly to sine, my domain will be negative infinity to infinity, and my range will be negative 1 to 1. In this case, the symmetry for a cosine graph is about the y-axis. My period is 2 pi again, because that's the length of my cycle before it repeats. My sinusoidal axes, again, same thing. It's that middle axis. Amplitude is that distance or that height of the wave, which is 1 again. Maximum and minimum value did not change because my range is still negative 1 to 1. My points of inflection will be slightly different. They'll be at pi over 2 and at 3 pi over 2. Because that's where those change from maximum to a minimum. All right, so now we're going to look at how transformations affect the sine and cosine graph. So if we're looking at this graph, my sine graph is this red graph here. And my y equals 3 sine of x is this graph here. And so I can see that my 3 sine of x has a vertical stretch by 3. And so what this is going to do is it's going to affect my range. So instead of being negative 1 to 1, which it is for the red graph, it's going to be negative 3 to 3. And most importantly, it also affects my amplitude. So instead of my amplitude being 1, my height of my wave is now 3. In the second graph, we're looking at comparing y equals sine of x, which again is this red graph, to sine of x plus 2. And so what's happening here is now we have a vertical shift up 2. So this is also going to affect my range, and so now my range actually goes 1, 2, 3. Because my lowest point is here at 1, and my highest point is here at 3. It's also going to affect my sinusoidal axes, which we abbreviate to SA. So instead of my middle being at 0, my middle is now at y equals 2. All right, the last transformation we're going to look at is what happens if we have a negative in front. So if I have y equals cosine of x is my red graph. My y equals negative cosine of x is my blue graph. So we can see that we have a reflection. In this case, it's across the x-axis. But in general, if we have a shift, it's going to be across the sinusoidal axis. So wherever that middle part is, we're going to reflect over that line. All right, let's take a look at a few more transformations. So my cosine of x is this red graph. My cosine of x minus pi over 2 is this blue graph. So what's happening here? I am seeing a horizontal shift right pi over 2. So keep in mind when it's inside the parentheses, if it's minus, it's right, and if it's plus in those parentheses, it's left. We call this horizontal shift a phase shift. So we call it phase shift pi over 2. If it was left, it'd be a phase shift negative whatever. So what does this mean? This means now instead of my graph starting at 0 and going to 2 pi, my graph now starts at pi over 2 and goes to 5 pi over 2. And that's because, again, my period is still 2 pi, so the length of my wave is still 2 pi, but since I shifted over, I need to have that other point. So it's going to go pi over 2, pi, 3 pi over 2, 2 pi. So then how do I get this next point? Well, 2 pi is the same as 4 pi over 2, so we're adding pi over 2 each time, and that's how I get 5 pi over 2. And that's the same pattern from here. If I add pi over 2, add pi over 2, so on and so forth. All right, let's look at what happens when we have something on the inside. So this one has 3 graphs. So let's first start off with my regular cosine is this red graph, and it's going 0 to 2 pi. Then I have the cosine of 2x. Now, that is this guy. And then I have the cosine of 1/2 x, and that is this guy. All right, so what's happening here? So in my blue graph, my b value is 2. In my green graph, my b value is 1/2. So what's happening is when I have a horizontal stretch, like I see in my green graph, that's going to happen if my b value is less than 1 but bigger than 0. In my blue graph, I can see that I have a horizontal shrink. And this will happen if my b value is greater than 1. And so the b value helps us determine the period. So the formula that we're going to use to determine what our period is, or how long our cycle is going to be 2 pi divided by b. This formula is going to be really important, so I'm going to put a box around it because we're going to use it every time to determine the length of our cycle. So for example, if my b is 2, if I do 2 pi divided by 2, the period for the blue graph was pi, which I can see it went 0 to pi. If I'm doing it for the green graph, I'm doing 2 pi divided by 1/2, which actually means I'm doing 2 pi times 2 over 1. So my period is 4 pi for that green graph, which I can see here it goes 0 all the way to 4 pi. So it helps us determine that length of that cycle. All right, before we get into graphing in the next video, the last thing we're going to do is just kind of look at some of these equations and identify the key features. Then tomorrow we'll get into graphing. So we are going to identify the amplitude, which I'm going to abbreviate to A, the period, which I'm going to abbreviate to P, the sinusoidal axes, which I'll abbreviate to SA, and the phase shift, which is our horizontal shift, but I'm going to abbreviate that to PS. And we're going to go over basically how to find all these things. So the amplitude is always our A value, and it's always going to be the number in front, and it's always going to be positive, so it's going to be 3. My period is always going to be 2 pi divided by my b value, and in this case, the number in front of x is 1, so my b value is 1, so the period is just 2 pi, which is kind of the default when our b is 1. The sinusoidal axis will come from looking if there's anything added or subtracted to my equation at the end, so if there's an up or down shift. In this case, there's not, so it's just going to be y equals 0. The phase shift is going to come from looking inside the parentheses with the x, so I'm going minus pi, so my phase shift is pi or right pi. Either way is good with me. It also wants us to predict 5 important angles in one period. So in this case, we are shifted right pi, so I'm starting at pi, and I'm going a distant. My length of my cycle is still 2 pi, so that means it's going to end at 3 pi, and that's because the length here is 2 pi, or pi plus 2 pi would give me 3 pi. So how do I figure out what my intervals are going to be in between? So I'm going to take the length of my period, which is 2 pi, and I'm always going to divide it by 4. And so that means my points are going to be pi over 2 apart. So if I do pi plus pi over 2, I'm going to get 3 pi over 2. Plus pi over 2, I'm going to get 2 pi. Plus pi over 2, I'm going to get 5 pi over 2. And then plus pi over 2, and I'm going to get 3 pi. And so those would be my 5 critical points. All right, let's do the same thing for B. So again, I'm going to determine the amplitude, period, sinusoidal axes, phase shift. So again, my amplitude is always my A value, so in this case it's going to be 5. My period is always 2 pi divided by B. My B value is 2, so 2 pi divided by 2, so my period is going to be pi. My sinusoidal axes, well, I'm shifting down 3, so it's going to be at negative 3. And my phase shift is negative pi over 2 or left pi over 2. Either way is good with me, and we get that from looking on the inside of my equation. So if I'm starting left pi over 2, that means I'm starting at negative pi over 2. And now the length of my cycle is pi. So negative pi over 2 plus pi, which would be negative pi over 2 plus 2 pi over 2, means that this is going to end at pi over 2. So I'm going to take my cycle, divide it by 4, that means my intervals are pi over 4. So I'm going to have negative pi over 4, 0, pi over 4, and then pi over 2. And those would be my critical points.